First of all, thank you, and I'm honored to be here today. It's good to see opportunity where veterinarian side comes because we're in the lab pushing out data a lot of the times. So I really enjoyed all the presentations I've seen so far. And today I just want to give you a little bit of insight of basically what FSIS does and our AMR efforts. So the title of my presentation is Antimicrobial Resistant Surveillance and Reporting and Food Safety Inspection Service. I'm an overview guy, so I can give you a little overview of what I'm talking about. Mission and background of FSIS, our role in NARMS, and you heard about NARMS a lot today and some yesterday. A little bit of history, a timeline transition from when NARMS and susceptibility testing moved from ARS to FSIS. We do take over the majority of the role, susceptibility testing. So data analysis, a little bit of AMR, what we do with it, how we collect it, analyze it, and put it into our reporting. Software tools we use, and the outcome of the data, and some of the AMR general investigations that we have been participating in. And one significantly highlighted here in my presentation is lytic-resistant and enterococcus gene associated with it. So FSIS and our mission, you can see the map here of our regulated and inspected establishments. We have about 6,400 approximately that we inspect and we get samples from. We have 3 labs, one in Athens, Missouri, and California. And we do random sampling in these establishments. And then we get the samples, and you can see they're enriched, screened, and isolated, and then sent to our branch for characterization. We still do PFGE. And we do, and the department that I'm back in now is Antimicrobial testing, so AST. We do molecular serotyping for Salmonella species, and of course, the new thing everybody's always talking about, whole genome sequencing. In AST, it's 10,000 isolates back there in one of those bullets, but lately it's been increased. We've around 12,000 now, I would say, to AST on at FSIS, especially the Eastern Laboratory. So how we fit into the NARM structure, you can see here highlighted in green, that we do random sampling of national production at slaughter of animal producing isolates. And we do 2 mechanisms of sampling, and I'll show you that next. Well, sorry, not next, but so here is our collaborating program and efforts. So you can see a timeline of how FSIS has taken over AST from ARS. 2013, sorry. They don't send me out much from the lab, so I get a little nervous when I speak in front of people. Sorry. So 2014 is actually when FSIS took over AST primarily from ARS. And the same, and then you can see PR and HACCP samples and sequel samples. And in 2013 basically when we started our sequel sampling program. That program is voluntary, so we really appreciate our inspectors sending us those samples to us because it's not really mandatory for them to. And we get a lot of useful data from that. It doesn't affect policy, but it's really useful and it's very interesting what we pull from that SQL data and AMR specifically. You see, 2015 we began WGS it's like the sequel sampling for Campylobacter and Salmonella. That was kind of based on their AMR profile from their phenotype. And we move on 2016, you can see that we started doing all the Salmonella and Campylobacter sequel samples, just fulfilling our obligations for reporting out more data. 2017, WGS for all Salmonella and Campylobacter. That means all sequel, all HACCP, all PR isolates that are sent to us and screened and isolated. And 2018, we started actually sequencing Enterococcus and we call it generic E. coli from the gut. We don't subtype it. So, and those are actually based on special phenotype that we correlate from our AST testing. Again, it's just showing you our sampling program pathogen reduction and hazard analysis critical control point (PR) and HACCP program started in 1997 to the present, and our sequencing sampling program that started in 2013 and is continuing now. And I told you earlier, a little side note, that samples are collected from the federal inspected slaughter and process plants throughout the United States, and the sequel sampling program is not regulatory, so results not enforced, but understand AMR microflora FSIS products. So at FSIS, like I stated earlier, we do antimicrobial susceptibility testing and interpretation, and to meet the standards of norms, we do follow their manual protocol methodology. So we follow the semi-automated bulk microdilution susceptibility testing method as described by norms and agent manager manual. And the criteria still followed by norms is the breakpoints established by the Clinical Laboratory Standards Institute, CSLI, for Salmonella, E. coli, Enterococcus. And for Campylobacter, epidemiologic cutoff values established by the European Committee on AST. So we collect this data, we collect MIC values for ambulatory concentration values for all our isolates. We collect that data and we transfer it into our labware system that we collect all our data and information into. And then that's stored into a SQL management studio where we collect all the MDR calculations, non-specific fields, WGS, and AMR genotype. So all our analyses are done in tandem. So we do PFGE, Salmonella, Septon Salmonella, AST, and genome sequence on all our isolates. And then we take that information and we can put it to interactive visualizations, and especially at some of our integrated data, we use Tableau for that. So AMR, FSIS, the outcome. Take the MIC values, CLI, ECOF breakpoints, and we get our interpretation to predict our phenotype. And then for whole genome sequencing, we take that data, sequence survey data, plug it into our bioinformatics, plug it into the res finder, point finder. We upload it to NCBI, our genotype. And we always try to make sure that our phenotype and genotype correlate, they're the same. And then we take that data that we get from that and we put it into the integrated surveillance reports. And you can see the note publication of integrated survey reports that consolidate phenotype and genotype data from all sources into the interactive format. And it hasn't been suggested earlier, but I recommend you go take look at the NARMS integrated report. It's very interesting and it's very interactive. You can see an example like Salmonella strains, the MDR, there's a decline, incline on certain ones, resistant to certain antimicrobials. Lastly, we use some of the data we have for our AMR-driven investigations. And you can see here one for linezolid resistance. I'll just read this pretty much on the slide. First, identification of linezolid resistant in the U.S. bacteria isolated from food animals. The linezolid resistant Optera gene and 3 Enterococcus isolates from sequel content. In addition to the linezolid resistant gene, CFR identified on the same plasmid as one of the isolates. And other resistant markers on these plasmids indicate co-potential for these plasmids, co-selection for these plasmids, and horizontal transmission into bacterial populations that cause human infection and concerns. So this is basically what our efforts in AMR is to just collect these samples and see how the antimicrobial is being used at, collecting at slaughter point, and we get in to see how, to see the fluctuations or just monitor the trends of antimicrobial resistance in food-producing animals. And this is my acknowledgement slides of, all our collaborating public health partners. And special thanks to them. And sorry for so quick, but I know I'm trying to get through before we can have some questions. Maybe I can get a better answer through questions and get a presentation. So thank you all for listening.